All right, my fantastic geometry students, we are on our way through factoring. We've now reached a point where we're going to look at what happens when we're factoring with a perfect square. What happens when we're factoring with a perfect square? The first question we need to ask ourselves is, what is a perfect square? So let's take a look at a definition. This definition is from the mathisfun.com website. It says that a perfect square is a number made by squaring a whole number. Anytime I have a number that is whole and I square it, the resultant number or the product is a perfect square. You'll notice the example they give you is 16 is a perfect square because 4 squared is equal to 16. 4 squared is equal to 16. So let's go back and look at our examples. What happens when I'm factoring a perfect square? Well, you'll notice that this looks very similar to the form ax squared plus bx plus c. And that is because it is in that form, except what is the value of b? Notice there is no bx term. This bx term does not exist, and that is because that value of b is 0. Anytime I multiply 0 by a variable, the resultant is 0. So when I FOIL, as you'll notice, that middle term, the bx term, will go away. So let's look at an example of how I would factor this problem, x squared minus 9. First thing I do is I recognize 9 as a perfect square. 9 is a perfect square for what number? Well, 2 times 2, or 2 squared, would be 4. And 4 squared would be 16, as we just saw. 3 squared is 9. So this looks like the perfect square, 3 squared, which is 9. So I make my factoring parentheses. I place an x at the beginning. I know that this value must add to be 0 in the middle, but it must multiply to be a negative number. So I'm going to have one positive and one negative. And I put in my 3's from my perfect square. And we'll see exactly what happens when I refactor, or excuse me, I FOIL this thing. First, outer, inner, last. I FOIL and multiply and distribute. First, x times x is going to give me an x squared. Outer, x times negative 3 will give me a negative 3x. Inner, positive 3 times x gives me a positive 3x. And my last values, negative 3 times a positive 3 is a negative 9. Let's look at that middle term, the one that we can always combine as like terms. I've got a negative 3 plus a positive 3, which is a 0 times x. So I have x squared minus 0x minus 9. And of course this middle term goes away. X squared minus 9. I look up at my original problem, x squared minus 9. My FOIL checks out exactly like I expected. Let's look at example 2. Example 2 has a perfect square, 100. That would be a value of 10 squared, or 10 times 10 is 100. So I make my parentheses. I know that I'm going to have an x at the beginning of each. I know that one is going to be positive and one is negative because this thing must multiply to be a negative number. And I insert my perfect square value, 10 and 10. Let's quickly FOIL. First, x squared. Outer, negative 10x. Inner, 10 times x. Positive 10x, looking good so far. And last would be a 10 times a negative 10, which would be a negative 100. Combine my like terms. This is 0. What I'm left with is x squared minus 100. I look back at my original problem, x squared minus 100. Everything checks out great. Now we move down to the bottom left, example 3. I have a number that's not as familiar to me as a perfect square. But I could use a calculator, or I could use what I know about multiplying values. All of my times tables I've got memorized in my head. And what I know is that 121 is 11 squared. I make my parentheses. I put my x's in the first position. One has to be positive, one has to be negative. My perfect square is this value. I place an 11 and an 11. Let's go back and FOIL. First, x squared. Outer, negative 11x. Inner, 11 times x is positive 11x. And last, 11 times 11 is a negative 121 because this second one has a negative value. Combine my like terms. It leaves me with x squared. This middle term is 0 minus 121. Look back at my original problem, and once again it checks out. One last example. I take my parentheses. I place my x's. I notice that 64 is the same as 8 times 8, or 8 squared. I'll place my 8's in. This time I'm going to place my positive and negative in last. Let's go ahead and FOIL. First, x times x is x squared. Outer, x times a negative 8 is negative 8x. Inner, positive 8 times x, positive 8x. And last, positive 8 times a negative 8 is a negative 64. My two terms add to be 0. Those terms go away, and I'm left with x squared minus 64, which is exactly what I started with. So that is factoring with a perfect square, possibly one of the easiest ways to factor if we can recognize that perfect square value.